Good afternoon, students. Am I audible to you?
Yes, sir. Good afternoon.
Let's wait for others for 2 minutes, then we'll start. कौन कौन से इंटरनल्स हो चुके हैं अभी तक? यस स्टूडेंट्स, कौन कौन से इंटरनल्स हो
सर
चुके हैं?
एक ही हुआ सॉफ्टवेयर इंजीनियरिंग का
ओके,
एंड सर मैथ्स का है ट्यूसडे को।
नेक्स्ट ट्यूसडे। ठीक है,
यस
we'll also schedule one soon.
ओके सर।
I think we should start. Let's not wait much for others. सबको timely join कर लेना चाहिए. Okay. In the morning, when the class had disrupted, we were discussing about 2D arrays. We'll start from very beginning क्योंकि सुबह प्रॉब्लम बहुत आई थी. So first of all, we'll import numpy as np. मैंने मॉर्निंग पूछा था कि जो मैंने असाइनमेंट दी थी कि रैंडमली नंबर्स को जनरेट करके एरे बनाना है. कुड यू डू दैट? ट्राई किया था आप लोगों ने?
सर किया था ट्राई बट रन नहीं हुआ वो।
कहाँ एरर आई थी? इसमें तो जो एरर्स भी जो होती हैं वो सेल्फ एक्सप्लेनेटरी होती हैं, पता लग जाता है कि क्या क्या रही है एरर. ओके, एनी हाउ, let's see first of all how to create 2D array, then how to use matrices, what are the different operations. We'll discuss all that. Okay, so first of all, let's decide what's the row, how many rows and columns are there. Let's get these from the user. C is equal to integer input, enter number of columns. Okay, so there are different methods by which we can create these arrays, 2D arrays. One is through list. What we can do is we'll declare an empty list, then using these parameters, rows and columns, we'll create a list. I in range rows for j in range columns. List dot append. Here we'll generate random number. I had told you that till now we were using random library or random class for generating random numbers. Now since we are using NumPy, NumPy has its own random number generator, so we'll use that. np dot random dot randint will specify the range from 10 to 100, and it will generate random numbers. Let's print the list first. Print generated list is /n so that it's printed in the new line. First, let us see what's the list. Say there are 3 rows and 4 columns. So this is the list generated. Through this loop, it will generate a list of 12 numbers, right? 12 random numbers. And then let us convert it to an array. Let it be array number 1, np dot array from the list, and dot will reshape it to, because list that we have created, it is consisting of all 12 numbers put together, right? When we are creating an array, 2D array from the list, then we'll have to specify its shape also. So we'll write R number of rows and C number of columns. Then let us print it. After conversion, the matrix is, or instead of matrix, let's call it 2D array, because in fact it is a 2D array only. So let's run it again. I'm giving 3 rows. Here I'm giving 3 rows and 5 columns. So you can see it here. It has generated a list of 15 numbers, and then we converted it to an array with the shape of R number of rows, C number of columns. So this is how we get it. This is a 2D array now. Is this thing clear?
Yes, sir.
Okay. Alternatively, we can also create an array AR2 is equal to np dot random dot rand int. Once again 10 to 100, and here we will give, if you can see it here, the prompt is telling you size also. So low is there, high is there, size is there. We have given low as 10, high as 100, and now size, according to the size it will decide whether it is a 1D array. If you are not specifying any size, it will be 1D array. Or you can see it here. Let's just print it once. Print AR2. Let's see what will happen. We need to specify how many elements. I'm giving 10. 10 means it will generate uh, an array of 10 elements probably. Let's see. Yes, you can see it here. The second one, it has generated a 1D array of 10 elements. Now, since we want a 2D array, we will provide the size in brackets, R number of rows and C number of columns. So these two will constitute the size. Let's run it again. After randomly generating array, 2D array, the values are AR2. Run it again. It's for the first row basically, and then there is a second row also. After randomly generating 2D array, ये first array है, ये second array है. Is this thing clear, बच्चे?
Yes, sir.
Okay. Then there are certain attributes of the array which we can use. Attributes like what is the dimension of the array, what is the shape, size, item size, data type of the arrays, and size in total size of the array in terms of bytes. So let us write all those one by one. First of all, we have dimension of the array is, here I'll write AR2 dot n dim. Okay. Let me write all the attributes at once, then we'll see क्या क्या आ रहा है. It will tell us what is the dimension of the array, whether it is 2D, 3D, or what. Right. Next is shape of the array is AR2 dot shape. I'm telling you these are attributes, these are not functions. We will not put any brackets here like this, right? These are attributes only. Then we have print size of the array is AR2 dot size. Let's see what's next. After size, we have size of each item of the array, right? Item size is AR2 dot item size. Print. Next, we have data type of each element of the array. Data type of array is AR2 dot D type, and last one we have size of the array, size in bytes of the array, AR2 dot n bytes. So let us check it. So this is for the first array. Size of the array is AR dot size of S capital del R. All attributes are in small size, small letters. Here you can see dimension of the array. We are talking about the second array which we have generated here, where we have given size as two dimension. One is row, second is column. So it is saying dimension of the array is 2. Shape of the array is 3 by 4. 3 rows, 4 columns, which we have entered here, right? Then next is size of the array. Size of the array means how many total elements are there. So rows into columns will give you the size, which is 12. Item size means what is the size of each item. Since data type of each item is integer 32, it means each item is of 4 bytes. What's the size of array in total size of array in terms of bytes? Size of the array into item size. Multiply these two and you will get total size of the array. Is it clear, bache?
Yes, sir.
Is it clear to all of you? Nitin?
Yes, sir.
Okay. Then there are some other functions which can be applied on arrays. For example, if you want to reshape it, let me declare ar3 dot ar2 dot reshape. Oh, sorry, ar3 is equal to reshape. I'm converting columns to rows and rows to columns. I'm just interchanging those and then print after reshaping the array is slash n. Since we have to print the array, let it be printed on the next line. Check it again. I am entering 3 rows and 5 columns. Oh, what's the error here? What happened here? Oh, sorry. 3 rows and 5 columns. You can see it here. This is the array which we have generated. Now, after reshaping, what it will do? First 3 elements will become first row. Next 3 will become second row. Next 3 will become third row. This is what has been done. The array has been reshaped. Earlier it was 3 rows, 5 columns. Now it is 5 rows, 3 columns. So it's very simple. Simply call the function and it will be arranged. Is it clear? Just in the same way, you can flatten an array. For example, if I have A4 is equal to AR2 dot flatten, what it will do, it will convert the array to 1D array. Print the array after flattening is slash n AR4. Once again, so you can check it here, the last statement. This array, it has been flattened to a one-dimensional array. Is it clear, bache?
Yes, sir.
Yes, sir.
Okay, I'll be discussing some problems related where we'll be covering many of these functions later on, right? First, let us understand what are the functions available or attributes available. Similarly, you can create an array of all ones. For example, AR is equal to NP. NP is number pi. Now, the ones function is part of uh, Numpy. We'll give the size as rows and columns, right? And the type integer. Print AR5. Let us see what happens here. You can see the last array. We have created an array of all ones where the size is or the shape is 3 by 5, right? 3 rows, 5 columns. If I change the type to float, all values will become float in that case. You can see the difference. Earlier they were ones only, now it is 1 point. It means it is in float. AR6, then we can generate an array of zeros also. Again, rows and columns. And again, we can specify the type as this. And let me print once again. AR6, 3 rows, 5 columns. You can see the last one is an array of all zeros. Then there is uh, there's a function through which we can generate an array whose all diagonal elements will be 0. Oh, sorry, 1. AR7 is equal to np dot I. We call it np dot I. This is the function. Here you will specify, since diagonals are involved, matrix will be or the 2D array will be a square array. You can either specify rows or you can either specify columns. Either rows or columns, whatever you want. Let it be columns. So after that we'll print it again. AR7. Run it again. 3 rows, 5 columns. You can see the last one, the last 2D array which has been created. Columns we had entered as 5. So this array is of 5 by 5 and all diagonal elements are ones. Is this thing clear?
Yes, sir.
Okay. Now, two more things: how to print the individual elements and how to print rows only. This is something very, very important. You need to understand this. For I in range, length of, let us take up some array. Let it be AR3. Length of AR3. Print AR3I. Let's see what will be printed here. 3 rows, 5 columns. You can see the last one. Array 3 is after reshaping. We had reshaped it to columns and rows. So it is 5 by 3 now. And if you look at these values, through this code, simple code, we are printing rows of the 2D array. This length, it will give you how many rows are there. This function, when you are getting length of a 2D array, it will tell you how many rows are there. And then each row will be printed. If you want to print individual elements of the array, 2D array, then you'll have to write 2 for loops. For example, let me show you here. For I in range, length of AR3, then for J in range, length of AR3I. Now it will give you length of each column. So you can print AR3I J just like matrices you use to print in C. And you'll see the difference now. In first case, we were printing each row. In second case, we are printing individual elements of the array. The way these are printed tells you whether you are printing rows or individual elements. Because in case of rows, the rows are enclosed in square brackets. When you are printing individual elements, then no kind of brackets are used. Is this thing clear, Bache? Hmm?
Yes, sir.
Okay, should we proceed? उसको क्या हुआ? Why has she left? Okay, let me save it and share the code with you. NP arrays. Now we'll shift to matrices. Once again, 2D array and matrix, otherwise they are the same. But in case of NumPy, we have a matrix class within it. Mansi, what happened? Mansi, perhaps same network issue. Okay, I was telling you, matrix is a specialized class available in NumPy. There are many functions which we can apply on matrices. So let's see how to create matrices in NumPy. Once again, let me pick up that same this piece of code. Let's copy that. So we were creating a list. Alternatively, what you can do, you can directly create a matrix, or you can create an array first. For example, AR1 is equal to np dot random dot rand int. I told you there are two ways of creating it, and then you specify the size. Print AR1. Let's see what happens here. 3 by 5 once again. Oh, what happened? Oh, sorry. These are to be given in separate rows. NP is not defined. Import numpy as NP. Now 3 rows, 5 columns, and the array is printed. And how to create a matrix out of it? Let me show you. Mi m1 is equal to np dot matrix ar1. This is one way. So we will print matrix here, print m1. They will look the same. As you can see, both of these look the same, right? कोई difference नहीं अभी लग रहा. The second alternative is you can provide list of numbers. M2 is equal to np dot matrix 1, 2, 3. Second list 4, 5, 6. Yes. Third is 7, 8, 9. So let's print M2. So this is again for the first matrix, and oh, got 4. What happened here? Oh, मैट्रिक्स था, हमने 3D बना दिया इसको. Just a minute. It would be like this: 3 rows, 5 columns. अभी क्या प्रॉब्लम हुई? Field element. अभी तो इसमें कोई प्रॉब्लम नहीं थी. Three or 4 tuple, but God, strange fool. Just a minute. 3, 5. अब तो ये चल रहा था भाई. मैट्रिक्स M2. ओके, चलो इसको देखते हैं ये वाला क्यों नहीं चला. लेट मी पुट कमेंट्स हियर. इसको बाद में देखते हैं. देयर इज वन मोर वे. यू कैन डिक्लेयर अ स्ट्रिंग like 1 space 2 semicolon 3 space 4 semicolon and 5 space 6, and then we can create a matrix out of it. M3 is equal to np dot matrix str, then print M3. Okay, this should work now. Yes, so it has created a matrix of 3 rows and 2 columns. Second method. Alternatively, you can write the string here itself. For example, if I write M4 is equal to np dot matrix within bracket, I can write it. Let me extend it a little more. 3, 4, 5, 6, 7, 8, 9. And then let's print this M4 matrix. So last one is 3 by 3. Second last is this, it is 3 by 2. Why this didn't work, I'll have to check again. Let's do it again. We are giving two lists. So it must be 2 rows, 3 columns. Why isn't it working? 2 or 3 tuples got 4. We are giving 2. चलिए कोई बात नहीं. We'll see later क्या problem है इसकी. Okay. I hope you remember for arrays we had used a function arange. It works here as well. One more method of creating matrix is equal to np dot matrix arange, say up to 12, and then we will reshape it to rows and columns. Instead of 12, let me write here rows into columns. That will tell us the size, and then we'll print it. Print M5, 3 rows, 5 columns. Oh, okay, A range. We need to write np dot A range. 3 rows, 5 columns. Oh, sorry, I have written 3 RC लिखना था, RR हो गया. Okay, 3 rows, 5 columns, and the last one is it will create an array using range from 0 to row into column -1. So we have entered 3 rows, 5 columns, that is 3 into 5, 15, -1 is 4, 0 to -1 is 14, 0 to 14 तक की values का matrix create हो जाएगा. Is this thing clear, बच्चे?
Yes, sir.
Okay.
Yes, sir.
Then very quickly, let us see a few more things. You can apply some other functions. For example, let me show you. Let me write those here first. We can apply operators like plus, minus, divide, and multiply. We'll apply these, we'll try these. And then we can have functions like min, max, and sum and mean on the matrices, just like we had on arrays. And then we can even sort the matrix. Then for sorting, we have two different methods. One is for sorting according to rows, another is according to columns. So let us discuss these and then we'll wind up the class. Okay, very quickly we'll go through all these. We have created matrix here. Even transpose of matrix can be done. Let us create two matrices and then we'll be able to do all this. So let me remove these from here. We have created one matrix here. Let me create one more. M1 is equal to np dot matrix. So after 10 minutes, class will be over. Okay, we won't be joining again. Whatever we'll cover within these 10 minutes, that will be sufficient. Okay, np dot random dot rand int 10 to 90, and then we'll specify the shape or the size. Let me print M2 got two matrices. Let me just print these 3 5. Matrix आना था चलो 3 5. So these are the two matrices which have been created. These are the two matrices, and then let us find out first the sum of matrices is, we'll write m1 plus m2. So here I'll write difference of matrices is m1 and product or multiplication of matrices is m1 into m2. Addition और subtraction के लिए एक rule होता है. Do you know what is that? What's that rule? For finding sum and difference of matrices, there is a rule. What is that? Anybody? Sum और difference के लिए अलग rule है, multiplication के लिए अलग rule है. What is that rule? Anybody? अरे मैट्रिक्स तो पढ़े होंगे. नितिन,
Yes,
what's the rule?
yes, sir.
Addition और subtraction के लिए rule क्या है?
Don't know.
Taranjeet, what's the rule?
सर फर्स्ट एलिमेंट मतलब
नहीं नहीं बेटा,
फर्स्ट एलिमेंट
वो तो आप एडिशन या सब्ट्रैक्शन का मेथड बता रहे हो, मैं तो रूल पूछ रहा हूँ. व्हेन एडिशन एंड सब्ट्रैक्शन कैन बी पॉसिबल, जब दोनों मैट्रिसेस का साइज या उनकी शेप सेम हो.
यस सर.
ओके. एंड मल्टीप्लिकेशन कब होती है? कैन वी मल्टीप्लाई दीज टू मैट्रिसेस? दोनों 3/5 3/5 के हैं. कैन वी मल्टीप्लाई दीज टू? हाँ, मल्टीप्लिकेशन का रूल क्या होता है? फर्स्ट के रोज सेकंड के कॉलम से इक्विवेलेंट होने चाहिए,
Yes, sir.
और फर्स्ट के कॉलम सेकंड के रोज के इक्विवेलेंट होना चाहिए, तब होता है. एम आई राइट?
Yes, sir.
तो इस केस में मल्टीप्लिकेशन नहीं हो पाएगी. सो व्हाट वी कैन डू, m2 इज इक्वल टू m2 डॉट ट्रांसपोज कर देते हैं. ओके, ट्रांसपोज कर देंगे तो फिर मल्टीप्लिकेशन पॉसिबल होगी. एंड लेट अस सी द रिजल्ट्स इन दैट केस. 3/4 का मैट्रिक्स ले लेते हैं. सो हियर वी गो. लेट मी राइट इट अगेन, लेट मी रन इट अगेन, जस्ट अ मिनट. स्लैश एन डाल देते हैं ताकि न्यू लाइन से स्टार्ट हो, एंड मैट्रिक्स का साइज भी रिड्यूस कर देते हैं, 2/3 कर देते हैं. And let us see here. So these are the two matrices. Sum of the matrix पता लग जाएगा. 64 plus 20 84, 79 plus 74 153. So sum तो ठीक चल रहा है, और difference it is 64 minus 20 is 44. difference भी ठीक आ रहा है, ठीक आ रहा है ना? And probably
यस सर.
तो probably इनकी मल्टीप्लिकेशन भी ठीक होगी. अच्छा, टेल मी वन थिंग. मैंने अभी m1 into m2 किया है. If I do it like this, m2 into m1, will it be same? Will it be the same or not?
Note, sir.
सेम होगा कि नहीं?
नहीं होगा, sir.
हाँ, फर्स्ट केस में तो आ रहा है 2/2 का, सेकंड केस में क्या आएगा?
Sir, 3/2 आ जाएगा.
वेरी गुड, 3/3.
Oh, 3.
2 rows 3 columns. देखो, फर्स्ट मल्टीप्लिकेशन 2/2 हुई, थर्ड मल्टीप्लिकेशन 3/3 हुई. द रीजन इज, पहला जो मैट्रिक्स है वो 2/3 का है, राइट, मल्टीप्लाइड बाय 3/2, ये बना ना. सेकेंड टाइम क्या किया हमने? 3/2 मल्टीप्लाइड बाय 2/3. तो फर्स्ट केस में जो होगा वो इसके अकॉर्डिंगली चलेगा. फर्स्ट की रोज सेकंड के कॉलम्स होते हैं, इसमें फर्स्ट की रोज 3 है, सेकंड के कॉलम 3 है, तो वो 3/3 का होगा. फर्स्ट वाला 2/2, सेकंड वाला 3/3. इज दिस थिंग क्लियर?
Yes, sir.
Okay,
यस सर.
now very quickly let us go through the other things. For example, हमने min फाइंड आउट करना है, मैक्स फाइंड आउट करना है. print min is m2 ही ले लेते हैं, m2 डॉट min max is max sum of all elements will be sum and mean of all elements will be mean. Let's see, 3 by 4. So in the second matrix, which is this, इसमें min कौन सा है? 16 11 max is 88. You can see it here, min
Yes,
is
sir.
11, max is 88. सारे एलिमेंट्स का सम हो गया और सारे
Mean हो गया.
एलिमेंट्स का मीन निकाल लिया हमने.
Mean हो गया.
Is it clear? So अगर इनको
Yes,
सॉर्ट
sir.
करना है, print sorted matrix is sort m2. So 3 rows 4 columns, sort is not defined, np dot sort होगा, 3 rows 4 columns. So here it is, you can see it is, its rows are sorted now. पहले क्या थी? These were the rows. Just a minute, कहाँ गया ये? हमने m2 को किया ना, यहाँ से स्टार्ट हो रहा है ये. m2 को ट्रांसपोज कर दिया था, ट्रांसपोज के बाद ये रोज बनेंगी. लेट मी राइट इट हियर, स्लैश n, पहले प्रिंट m2 डायरेक्ट कर लेते हैं, देन आफ्टर सॉर्टिंग 3 by 5 कर देते हैं. ओहो, 3 by 5. So here is the unsorted array or a 2D matrix, and here is the sorted. You can see 12, 80, 40 है. The rows have been sorted here. सेकेंड रो भी सॉर्ट हो गई है. तो हर रो के एलिमेंट सॉर्ट होकर आ जाएंगे. और अगर हमने इसकी कॉलम वाइज सॉर्टिंग करनी है, देन यू विल राइट प्रिंट sorted columns are np dot sort m2 and x is 0. अब देखते हैं क्या बना. देखो इसके कॉलम सॉर्ट हो गया है. here's the original matrix. यहाँ स्लैश n लगा देते हैं, then it will be clear to you. Let me run it again. Okay, here you can see this is the original matrix, 29, 15 and so on. So इसके कॉलम सॉर्ट हो गए. सेकंड केस में हमने एक्सिस को 0 कर दिया. अगर डिफॉल्ट वैल्यू यूज कर रहे हैं तो उसकी रोज को सॉर्ट करेगा. अगर एक्सिस दे रहे हैं 0 तो उसके कॉलम्स को सॉर्ट करेगा. राइट. Similarly, we can find product of rows and columns. Print product of rows is np dot product 1. Print product of columns is np dot product. Just a minute, np नहीं आएगा, यहाँ मैट्रिक्स का नाम आएगा m2 0. अगर 0 करेंगे तो ये कॉलम्स की प्रोडक्ट होगी, अगर 1 करेंगे तो रोज की प्रोडक्ट देगा. यू कैन सी इट हियर, ये रोज की प्रोडक्ट आ गई